Heat now has an on-off switch. The phone in your hand, the laptop on your desk, they're all getting hotter and slower because of a fundamental limit of physics we couldn't bypass. Until now. Researchers at the University of Chicago just created a solid-state thermal switch that can precisely direct heat on command. A breakthrough that could make our computers 10 times more efficient. But the real story isn't just faster phones. It's about a new form of control over energy that could make entire industries obsolete. And it all starts with a device that acts like a one-way street for heat. For 50 years, our solution to heat has been brutishly simple. Get it out. We use fans, spinning blades of plastic, and giant metal heat sinks. Passive, unintelligent systems that just radiate heat away into the air. This waste heat is the single biggest bottleneck in modern technology. It throttles the performance of your brand new iPhone. It limits how fast your EV can charge, and it forces data centers to spend up to 40% of their electricity bill, billions of dollars, just on cooling. We've been fighting a fire with a bucket when what we really needed was a way to tell the fire where to go. The dream has always been a thermal diode, a device that allows heat to flow in one direction but not the other. But building a one-way gate for something as chaotic and fundamental as thermal vibration seemed impossible. How do you stop the jiggling of atoms from jiggling back? The team at the University of Chicago's Pritzker School of Molecular Engineering found the answer not in brute force, but in quantum mechanics. If this is the first time you're seeing how quantum physics will cool your next laptop, subscribe. We decode breakthroughs like this every single week. Their device uses two thin sheets of graphene suspended just a few hundred nanometers apart. When the sheets are aligned, the heat carriers, vibrations called phonons, can easily pass from one to the other. Heat flows. But when they slightly misalign one sheet, the paths for those vibrations no longer line up. The phonons get scattered, blocked, heat stops. The result is a solid-state device with no moving parts that acts as a thermal switch. And the performance is staggering. They achieved a rectifying effect of over 1,000 to 1. That's like having a window that's 1,000 times better at letting heat out than letting it in. But they didn't stop there. By applying a small electric field, they discovered they could control this effect on demand, turning the heat flow on and off like a light switch. This elevates the device from a simple diode to a thermal transistor, the fundamental building block for controlling and processing heat itself. So what does a world with programmable heat actually look like? For you, it means devices that feel like they're from the future. A laptop that runs intensive tasks for hours without the fans ever kicking in. A phone that doesn't get hot and slow down while gaming or shooting 4K video. It means your next electric vehicle could charge significantly faster because the heat can be actively pumped away from the battery cells, preventing degradation. For industry, this is a revolution. Data centers, the backbone of our digital world, could replace their massive, energy-guzzling air conditioners with silent, solid-state thermal management systems integrated directly into the servers. The energy savings would be in the billions of dollars. We could see new manufacturing techniques where heat is applied with surgical precision, or smart buildings that intelligently route solar heat from the sunny side in the morning to the cold side at night, virtually eliminating heating and cooling costs. We're moving from an era of simply dissipating heat to an era of directing it. This isn't just a better heatsink, it's the beginning of thermal circuits. As we gain perfect control over energy, will this power be used to create unimaginable efficiency? Or will it just enable a new, more power-hungry generation of technology we can't yet predict? Today,
We saw how a breakthrough in quantum mechanics created the world's first true thermal transistor, giving us the power to direct heat on demand. To stay ahead of the technologies that will redefine our energy and computing landscape, make sure you're subscribed. Next week, we're decoding NASA's $10 billion gamble on finding life, and why a strange signal from an ocean world has scientists holding their breath. The future, arriving sooner than you think. The future, decoded.